In 1942, the blue expanse of the Pacific was not just a battlefield. It was a vast, unforgiving void where the reach of a nation's power was measured by the clarity of a young man's eyes. Imagine a pilot barely 20 years old, strapped into a cockpit of rattling metal and glass. His view of the world is filtered through a canopy stained with oil and salt spray. To his left and right, his brothers in arms fly simple machines, steel boxes sheathed in wood, carrying unguided bombs that must be dropped with the precision of a prayer. This was the Battle of Midway. There were no satellites, no digital uplinks, no certainty. Victory in those days was a fragile thing, woven from the threads of raw bravery, the sudden appearance of a cloud bank, and the sheer terrifying luck of spotting an enemy fleet before they spotted you. It was a war of visible horizons and human limits. Now let the decades slide away. 80 years have passed, like a tide receding and returning transformed. Stand on the deck of the USS Gerald R. and you might feel a sense of haunting familiarity. The geometry remains the long, flat expanse of the flight deck, the towering island, the sense of a floating city carved from iron. But under the skin of this 100,000-ton Titan, the very nature of existence has shifted. We have moved from the era of burning heavy oil to the age of splitting the atom. The binoculars that once strained to catch a glimpse of a mast have been replaced by AESA radar's active electronically scanned arrays that do not just see across the water, they pierce the veil of space itself. Yet in this temple of technology, a shadow lingers. History teaches us that nostalgia is a luxury the warrior cannot afford. While we marvel at our progress, the physics of destruction has not stood still. In 1942, a carrier captain feared the slow rhythmic drone of propeller planes and the lumbering path of a dumb torpedo. Today, the threats are invisible until they are lethal. We live in the shadow of the anti-ship ballistic missile. We face hypersonic warheads that scream through the atmosphere at Mach 5 weapons so fast they turn the air around them into glowing plasma. We face swarms of suicide drones, autonomous hunters that feel no fear, no fatigue, and no hesitation. The world has become faster, smaller, and infinitely more dangerous. It forces a question that haunts the halls of the Pentagon and the minds of every naval strategist. Why? Why do we continue to build these massive 100,000-ton targets? In an age where big often translates to dead, why place 5,000 American souls onto a single hull? Is it a sentimental attachment to the ghosts of World War II? A refusal to let go of the carrier's golden age? The answer is colder than nostalgia. It is found in the intersection of geometry and industrial will. The Ford was not built to win the Battle of Midway again. It was built to bend the laws of physics until the enemy's math no longer works. It is a machine designed to project a kill web, so mathematically absolute that no firing solution can penetrate it. To understand this, we must look past the steel and the bravado. We must look at the real enemy. The carrier's greatest adversary is not a specific nation or a particular missile. The enemy is the Earth itself, specifically the relentless, unchanging curvature of the planet. This is the geometric nightmare of the tactical officer, the radar horizon. Physics is a ruthless judge. Radar energy, for all its power, travels in straight lines. The Earth stubbornly is a sphere. Unless you are utilizing massive low-resolution backscatter systems, you are a prisoner of the line of sight. Consider the modern anti-ship cruise missile. A sophisticated enemy does not fly their weapon at 30,000 feet, where our most advanced SPY-6 radars can track it from hundreds of miles away. They fly low. They sea-skim hug in the whitecaps at an altitude of perhaps 30 feet. At that height, the very curve of the ocean acts as a perfect natural cloaking device. Even if you place your radar sensor at the highest point of an Arleigh Burke-class destroyer, roughly 100 feet above the waterline, the math is unforgiving. Your radar horizon is limited to about 20 to 30 nautical miles. Beyond that line, the world is a blank. The missile is not just coming, it is hiding behind the horizon. Now introduce the variable of velocity. If that incoming threat is a supersonic missile traveling at Mach 3, it will cross those 30 nautical miles in less than 30 seconds. 30 seconds. In that heartbeat of time, a crew must detect a blip emerging from the clatter of the waves, classify it as a mortal threat, compute a complex firing solution, and launch an interceptor. It is a dead zone where billion-dollar technology is rendered useless by the simple lack of time. Physics does not care about your defense budget. It does not care about the righteousness of your cause. So how does one survive the impossible? How do you neutralize a threat that you cannot physically see until it is too late? The solution was not to build a taller mast or a faster ship. The solution was a fundamental surgical separation of the eye from the fist. The United States Navy realized that to survive they didn't just need better weapons, they needed a new nervous system. They called it NIFCC, Naval Integrated Fire Control Counter-Air. Behind the sterile military acronym lies a revolution in the philosophy of war. In the old world we relied on a kill chain. It was a linear, fragile thing. Ship A sees the target, Ship A shoots the target. If Ship A's vision is obscured or its sensors jammed, the chain breaks and the ship dies. NIFC-C shatters that linearity. It transforms the chain into a web, a system of systems where data flows like blood. Imagine a destroyer sitting in the vast stillness of the ocean. It launches an SM-6 missile at a target its own radars cannot see. The ship is effectively firing blind, yet the missile is guided with surgical precision. How? Because the destroyer has borrowed the eyes of an E-2D Advanced Hawkeye or an F-35 Lightning II flying hundreds of miles downrange. This is not a pilot shouting coordinates over a crackling radio. That is too slow, too human, too analog. This is fire control quality data transmitted at the speed of light. The destroyer's fist is guided by a distant eye. This is engaged on remote. It pushes the radar horizon back until the constraint of the Earth's curve is neutralized. The horizon is no longer 30 miles away. It is wherever our furthest sensor is flying. But a nervous system, no matter how brilliant, requires muscle to act. You need a weapon that can reach into that distant, dark, and strike. This is the genesis of the AIM-174B, a weapon, born of engineering desperation and brilliance. The challenge was simple. The FA-18, Super Hornet, needed the reach to kill enemy eyes, their AWACS and bombers before they could ever see the carrier. But traditional long-range missiles were too heavy for the nimble fighter. The engineers looked at the SM-6, a 20-foot 300-pound monster designed to be launched from the vertical tubes of a ship. It was too massive for a jet to carry into a dogfight, so they made a trade-off. They stripped away the heavy Mark 72 solid rocket booster, the first stage meant to lift the missile off a stationary deck. They realized that the Super Hornet itself is the first stage, launched at 30,000 feet while traveling at Mach 0. 8. The missile begins its life already imbued with massive potential and kinetic energy. When the pilot releases the AIM-174B, the physics of flight takes over in a way that feels almost alien. The missile does not fly straight, it lofts. It punches upward, climbing into the thin cold air of the stratosphere, reaching altitudes of nearly 100,000 feet. Why? To escape the eternal enemy of speed friction. At sea level, the atmosphere is a thick soup that drains energy through drag and heat. But at the edge of space, the air is a near vacuum. The missile doesn't fight the atmosphere. It glides through it with near zero resistance, conserving its kinetic energy over hundreds of miles. When it finally nears its target, it dives. Gravity, the very force that usually weighs us down, becomes a force multiplier, converting potential energy back into a terrifying velocity of Mach 3.5. It is a masterpiece of systems integration, a way to sanitize the airspace and blind the enemy before they even know a battle has begun. Because in the modern era, a blind enemy is a dead enemy. But even with the sky sanitized and the long-range threats pushed back 200 miles, the modern naval commander is a cynic. He knows that in the chaos of a real conflict, leakers are inevitable. Somewhere a missile has slipped through the outer screen. Somewhere a saturation swarm of low-flying drones is closing in. This is where the defensive layers of the kill web activate, moving from the theater of physics to the theater of the mind. The philosophy here is distinct. To shoot a missile down with another missile is a feat of brute force. It is hard kill, effective but expensive, risky, and limited by the number of interceptors in your magazine. To make that missile blind, to make it go insane, or to leave it wandering lost in a digital haze is something much more elegant. This is the soft kill. As a threat approaches the hull of the Gerald R. the first line of defense isn't a kinetic explosion. It is high-energy radio frequency. This is the SWIP block, 3 Surface Electronic Warfare Improvement Program. Forget the old concept of jamming, which was simply noise, the electronic equivalent of screaming in a library to prevent a conversation. SWIP is infinitely more malicious. It uses digital radio frequency memory D, RFM. Think of it as a predatory tape recorder. As the enemy missile's radar sweeps the ship, SWIP captures that exact signal. it digitizes it, modifies it, and blasts it back at the missile through powerful ASA emitters. It doesn't just drown out the signal, it deceives it. The missile's computer begins to see thousands of ghost targets. It sees a ship that looks real but is electronically shifted several hundred meters to the left. The missile suffers from electronic hallucinations, eventually diving into the empty, indifferent ocean, convinced it has struck its target. But what if the missile is smart? What if it is designed to home on jam, turning your own electronic defense into a beacon? We transition to the second layer. The Nulka Mark 53. Most people think of decoys as chaff, strips of aluminum foil fluttering in the wind. The Nulka is a different breed of aerospace engineering. It is a hovering rocket. Once launched, it uses complex thrust vectoring to hang stationary in the sky away from the ship. When activated, the Nulka's electronic payload blooms across the electromagnetic spectrum. It presents a radar cross-section 10 times larger than the aircraft carrier itself. To the simple predatory logic of an incoming missile, the Nulka is the better target. It looks brighter, bigger, and more important. Like a matador leading a bull with a red cape, the Nulka seduces the missile, slowly flying it away into the void until its fuel or its patience runs dry. Assume for a moment the worst, assume the electronic warfare has failed, the seduction has been ignored, the missile is still closing at Mach 2, the roar of the ocean beneath it a blur. Now and only now does the Navy resort to kinetics. The first kinetic layer is the ESSM Block 2 evolved Sea Sparrow missile. The breakthrough here is the shift from semi-active to active radar, homing. In the past, the ship had to act as a flashlight, illuminating the target with its own radar for the missile to follow. This created a lethal bottleneck. A ship only has so many flashlights. If 50 missiles attack at once, you run out of channels to guide your interceptors. The ESSM Block 2 carries its own radar in its nose. The ship can dump its entire magazine into a swarm and let the missiles hunt on their own. It turns a defensive struggle into a swarm-on-swarm battle. If the threat survives the Sea Sparrows, it enters the point defense zone. Here we find the RAM, the rolling airframe missile. Its name is the key to its engineering. The entire body of the missile spins like a bullet from a rifle. This rotation stabilizes the weapon's flight without the need for expensive complex steering fins or internal gyros, allowing for a reaction speed that is almost instantaneous. It is a dual-threat hunter seeking out both the enemy's radar signal and the intense heat of its engine. And then there is the final resort, the last ditch, the Phalanx CIWS, a 6-barreled Vulcan cannon that sailors affectionately call R2-D2 with a bad attitude. It fires 4,500 rounds of heavy tungsten per minute, creating a literal wall of metal in the air to shred the airframe of an incoming warhead. But the Phalanx has a fatal flaw: logistics. It carries enough ammunition for only about 20 seconds of continuous fire. 20 seconds. That is the razor-thin margin between the survival of a $13 billion ship and a catastrophe. This brings us to the ultimate problem of modern war. It isn't just about speed or stealth, it is about the salvo equation. An SM-6 interceptor costs over $4 million. A suicide drone might cost $10,000. If we use million-dollar missiles to swat away cheap drones, we go bankrupt, long before we run out of courage. It is economic suicide. The solution to this final math problem is light, the Odin and Helios laser systems. What is the cost per shot for a laser? About $1 the price of the diesel fuel needed to run the ship's generators. We don't need to physically blow a drone apart. We use the Odin to dazzle its optical sensors, burning out its cameras and blinding its digital brain. At the speed of light for the price of a cup of coffee, the threat is neutralized. This is how a carrier maintains its magazine depth in a war that could last months rather than days. Take one last look at that ship silhouetted against the rising sun. The critics and the armchair generals call it a target, a 100,000-ton relic waiting for its inevitable end. I call it a monument to industrial audacity and a testament to the fact that we refuse to be victims of physics. If you share that conviction, if you believe in the cold weight of American iron and the fire of the American soul, do not wait. Hit that subscribe button and type unstoppable in the comments right now. Let us make sure the algorithms of this world hear us as clearly as an Aegis radar pings the horizon. Before we disconnect, I want you to think back to where we began, 1942, the Battle of Midway. Back then, the survival of the free world rested on the shoulders of 20-year-old kids. They flew into walls of anti-aircraft flak with nothing but a manual gun sight and the hope that their luck would hold for one more minute. Many of them never saw the carrier deck again. They were heroes who fought with the raw bleeding edge of courage, because that was all they had. Fast forward 80 years to the USS Gerald R. The technology has changed beyond the wildest dreams of those 1942 pilots. We have traded wood for composite oil for the atom and binoculars for space-faring sensors. But the spirit has not aged a day. The young sailors standing watch on this deck today have the same blood running through their veins as the giants who fought at Midway. The difference is that today we treat their lives with the reverence they deserve. We no longer ask them to rely on the whims of the wind or the thickness of a cloud bank. We honor their bravery by arming them with the cold calculated certainty of mathematics. We took the bravest souls on earth and we gave them unfair advantages. We gave them the ability to see the invisible, to strike from the stratosphere, and to weave a web of protection that moves at the speed of light. We didn't build this machine to replace the American warfighter. We built it to make them invincible. That is the true definition of power. It is not just the steel and it is not just the algorithms. It is the fusion of American grit with American engineering. Our adversaries can copy our chips. They can attempt to steal our blueprints. But they cannot replicate the heart of a sailor standing watch in the Combat Information Center, and they certainly cannot replicate a system that amplifies that sailor's will into kinetic destruction. Engineering dictates the strategy, but it takes a human to execute it. Right now, that combination human will plus technological supremacy owns the electromagnetic spectrum. It is quiet, it is heavy, and it is inevitable. We have evolved from throwing heroes at a problem to building a machine that ensures our heroes come home. This is what happens when you combine the pursuit of liberty with the mastery of logistics.